Okay, right now I wanted to show you how a galvanic cell works, and this is maybe my favorite part of chemistry. This is electrochemistry. So let's get some things out of the way with electrochem. Okay, you're gonna need to learn these two phrases. Okay, oil rig and NOx red cat. Now, oil rig stands for oxidation is the loss of electrons. Reduction is the gain of electrons. Now, that sounds confusing. Reduction is gain? Yeah, well, of electrons it is. It's the gain of a negative charge. Anox is talking about the anode, that oxidation occurs at the anode and reduction occurs at the cathode, okay? All right, we're gonna have to figure out some things. Okay, so this is a galvanic cell. In other words, it's a battery, okay? So this is when we see electrons moving from one side to the other. And how do chemists predict which sides electrons are gonna move? Now, I wanna show you, okay, let me get this guy out of the way. Anox, red cat, oil rig. Let's look at what's happening in the zinc. The zinc in this reaction is going from a neutral charge to a positive charge. And how would it become positive? Well, it lost its electrons. If it lost its electrons, it oiled. In other words, it oxidized. Okay? See, the zinc is losing electrons, therefore it's becoming positive. That's what this is showing. On this end, look at the copper. This is the other way around. The copper is gaining electrons. The copper in the solution is the copper 2+. It's gaining electrons. It's going from being positive to neutral. Yeah? If it's going positive to neutral, that means it's losing positivity. It must be gaining negativity. And remember, electrons are negative. So as this copper here is positive, becoming neutral, it is gaining electrons. So this is rigging. Reduction is gain of electron. In other words, the copper is reducing. Okay? Well, if the zinc is oiling anox, this is our anode. And if the copper is reducing, red cat, it is our cathode. Now let's look at what's happening here. See, they actually wrote that for us. If you see, the zinc is the anode, the copper is the cathode. Okay. Now, what does that mean? That means, okay, remember, our zinc is losing the electrons. It's sending the electrons this way. And our copper is gaining the electrons. So the electrons are going from left to right in this picture. Now, notice this solution. This solution is filled with zinc nitrate. Now that zinc, oh, they kind of messed up here. That's zinc 2+, okay? There's zinc 2+ in this solution. And what's gonna happen? This is a bar of zinc. Now, not zinc 2+, it's a bar of zinc, like zinc, like Zn, no charge, okay? Well, as this Zn right here is losing electrons, guess what's happening to it? It's becoming more and more zinc 2-. Okay? This solution is filling up with zinc 2-. Why? Because this anode is going to get skinnier and skinnier and skinnier, and it's going to start to decompose. Why? Because these zincs here are sending their electrons. And when they send their electrons out, these zincs will become zinc 2+. They will join the solution, and this anode is going to eventually deteriorate. All anodes deteriorate. Now think about this copper. See, in this copper, you have copper 2+ in the solution. You have a bunch of copper 2+ in the solution. So notice that we did that. We put zinc in zinc solution, and we put copper in copper solution. But what's happening on this side? This side is receiving electrons. Electrons are coming down this way, and as there are extra electrons kind of floating on this thing, this copper 2+ looks at an opportunity. They say, hey, you know what? I don't want to be copper 2+ anymore if there's electrons around. And he grabs that electron and he becomes more copper. In other words, this copper cathode is going to eventually increase. Okay? So the electrons are going from left to right, and you're definitely seeing the anode, where it's oiling, losing electrons and actually shrinking. This solution over here is going to become, if you think about it right here, this solution is going to become, how do I do this? It becomes darker and darker. It becomes more filled with more Zn, more Zn, more Zn. It's just going to get really filled with Zn2 pluses, because all this Zn, you know, again, from here is going to decrease. Now, if you think about this solution is going to get lighter and lighter. Ooh, I can't even paint on here. Hold on. I don't know why. Yeah, it doesn't work. But this solution is going to get lighter and lighter. I can't even draw on here. Or this is going to get lighter and lighter because the Cu2 pluses in the solution are going to become Cus on top of the cathode. Okay. Now here's the last piece. Right here is known as the salt bridge. The salt bridge has a salt in there. In this case, it was Na2 plus. Now think about what's happening in the salt bridge. Like we said, this left side is increasing in Zn. I should use a darker color. Okay, it's increasing in Zn2 plus. There's more Zn2 plus. There's more Zn2 plus. So inside the salt, the anion of the salt is attracted to that Zn2 plus. The anions will go left. On the other hand, this is losing, the Cu2 pluses are starting to go away, right? As the Cu2 pluses go away, as they go away to become copper, you're losing positivity. This solution is slowly becoming more negative because only the NO3s are there. That means the positive side wants to go to this negative solution, okay, of that salt. Okay, this is how a galvanic cell works, okay? And galvanic cells are naturally going to happen. They are spontaneous. Their delta G is negative. I'll talk about that in another video next time. But let's go to a question. All right, I'm going to go to the ChemAP. The ChemAP test from 2014 to look at this. See, I can see that this is a galvanic cell. I see that there is a bunch of copper 2 pluses in this solution, and that there's a bunch of tin 2 plus in this solution. Now, let's read this question. A student is given a standard galvanic cell represented above that has a Cu electrode and an Sn electrode. As the current flows through the cell, the student determines that the Cu electrode increases in mass. So, okay, the Cu is starting to get bigger. And the Sn decreases in mass. So the Sn is starting to get smaller. So what's happening? That means electrons are leaving the Sn and going to the Cu. And as it goes from the Sn, as this solution is starting to create more Sn2 plus, Sn2 plus, because this Sn is losing electrons, it's becoming the Sn. So you again have this Sn becoming Sn2 plus. How does it become 2 plus? It must have given away 2 electrons. So what is happening here? If it is giving away its electrons, the Sn side is rigging. If it is rigging, this is the cathode. Okay. Reduction. Oh, sorry. No. I totally messed up there. If it is losing electrons, it is oiling. Oxidation is the loss of electrons, right? It is losing electrons. Therefore, this is the anode. On the other end, what's happening here? Cu is gaining 2 electrons to become, Cu2 plus is gaining 2 electrons to become more Cu. If we're getting more Cu, because this is just increasing, as the electrons arrive, the electrons are over here, the Cu2 plus is going, hey, like, I have a chance to become Cu, and it does, and it combines with those electrons, so it becomes copper. So that's why the mass of the Cu is increasing. So what is this? What is the left side doing? It is gaining electrons. It is rigging. If this is rigging and it is reduction, then reduction happens at the cathode. Red cat. Cathode. Okay. All right. I kind of gave away some of these answers, but look at A. It says, identify the electrode at which oxidation is occurring. Who's oxidizing? This is oxidizing. Sn is oxidizing. He is losing the electrons. Explain your reasoning behind the student's observations. How would you know that side is oxidizing? Well, because the Sn is decreasing in mass, meaning the Sn is falling into the solution as Sn2+. As the mass of the Sn electrode decreases, where does it go? It goes into the solution. Now it says, in the expanded view of the center portion of the salt bridge, in the diagram below, draw and label a particle view of what occurs in the salt bridge. Okay, so we have a KNO, so you have the K pluses and the NO3 minuses, right? Now, the Kn is going to go to the solution that is becoming more positive. Which solution is becoming more positive? This solution is becoming more positive. There's more Sn2 pluses. Look, electrons are leaving this side. If electrons are leaving that side, then this side is becoming more positive. Electrons are coming to this side. So this part is becoming more negative. So the part that's becoming more positive is going to attract the NO3. The part that's becoming more negative is going to attract the K+. All right, hopefully that helps jog your memory on how a galvanic cell works. I just want to remind you that an electrolytic cell is the exact opposite. An electrolytic cell doesn't happen spontaneously. It has a delta G that is positive, and yeah, the cathodes and the anodes, it's going to still do the same thing, but there's a little bit more work to be done with an electrolytic cell.